All right. So, what's that? That's Polaris. And it's like, if I had Brian's broom again, I'd point the broom there, right? Okay. But the thing about the Earth's axis of rotation is it has, through the course of, I'll go ahead and put this up here, through the course of 26,000 years, it'll keep that same tilt, but just like you kind of see that top kind of going like this, it kind of cones around. Okay? So right now it's pointing to Polaris. Okay? At one point it was pointing to Vega. Okay? And then it kind of cones back around again. We call that kind of wobble precession. Okay? It's still tilted, so we still have seasons. Speaking of seasons, kind of because of the tilt, our seasons will happen slightly at a different month. It's called the precession of the seasons. The seasons will kind of process. We won't see it because it happens over the course of 26,000 years. Okay, so it's called precession. All right. Precession of the equinoxes. So that's pretty simple. Okay, now we get to talk about the moon. So, the moon orbits the Earth, okay? And the reason we see the moon is because of the sun. If the sun were to blink out, we wouldn't see the moon. We'd run right into it. No, actually, we wouldn't because it's orbiting and it's going to keep orbiting us. But the only reason we see the moon is because the sun shines on it, and that sunlight then goes in all directions, and one of the directions sometimes is our direction. So the moon at all times is getting half lit up by the sun. Okay, half lit up by the sun. And how much of that hemisphere that's lit up that we see depends upon where the moon is in orbit about the Earth. And I've got some figures to try to kind of convince you of this. But I think this is going to work just fine. So I'm still going to be the Earth, and when I hold out my fist like this is going to be the moon. And we're going to try that. Okay, so sun, Earth, moon. Okay. So the moon goes around. It takes about 29 days for the moon to go around the Earth once. Okay. It's kind of nice because if you take 29 and a half days or so, and if you round it to 28 days, it's kind of nice because the beauty of 28 days, it's divisible by 4. So 28 days to complete one cycle. If you divide that into quarters, you get 7 days here, 7 days there, 7 days there, 7 days there. Okay? So that's kind of helpful. Okay, what else we got? Let you kind of fill in some blanks. So as I'm standing here, remember I'm the Earth. Okay, and this is the moon, the sun. Okay. Do you see where it's kind of cool that like wherever the moon is, okay, it's being lit up by the sun. Okay, and so as I hold my hand like this, can you see where the sun is lighting up the moon? And if we see the moon, and if the Earth's not in the way, we'll talk about eclipses here in a minute. If the Earth's not in the way, we're actually going to see a whole circle of the moon. Does that make sense? Okay. And I told you 7 days and then 7 days, okay, for the moon to go 2 parts. If the moon's right here, okay, can you see that the lit up part is, we're not privy to it yet. We don't see it at all.
Well, like the one we just seen, the crescent moon, you can still see the rest of it.
Yes. That's something called earth shine. And actually I've been kind of going, all my circles are going to go, the moon is actually going to have to go this way because the moon goes counterclockwise around the Earth. Okay? So the thing about earth shine is we're just coming out of new moon. Okay? So here's the moon, what was new, now it's going like this. On your sky maps, did you see it kind of move that way? Okay? On your sky maps. So the moon's there now. And now we see just a sliver over here. If you go back and see the moon tonight, you kind of see a sliver over here. And like you were saying, we see the rest of the moon. How's this work? Because the sun is shining on the Earth, and some of that light is going in all directions. It's actually Earth's light is going back up to the non-illuminated part of the moon and shining it up. So it's Earthshine. And I have a link on my science Twitter feed because I was just curious about that recently. And it's Earthshine is most predominant like within 5 days, or up to 5 days after new moon. So kind of what I said is what we need to kind of emphasize. So tonight's moon is a crescent. It's a sliver. It's a thumbnail, I like, somebody said. Okay? So tonight's moon, if you go see it, it looks kind of like that. And yeah, you can kind of right now see the dotted rest of it. But the stuff there on the left is bright. So the stuff, or the region between, if this is bright, I'll put bright, that's, ugh. The place between, oh, come on. I'm trying to say what a terminator is. I'll be back. No. Right there is the terminator. There's the terminator tonight. It's the place where the lit part stops and the not lit part starts, or vice versa. Okay? And if you're looking through a telescope, a lot of times the person who's running the telescope, or you can run the telescope, sometimes you can just make it, that's where you want to look, because that's where you can kind of see some kind of mountains and valleys and stuff. Shadows are really cool with the terminator. Okay, so she is kind of like what I did. She's the Earth. And you see those balls around there are the moon. Oh, she's really...
I'm like so stuffed up with my allergies are killing
I can
me
tell.
now that I'm like dying over here, but I'm trying to be so quiet.
You just want to... You're doing a good job of it.
Excuse me, so
You're being
I'm in the
sneaky.
bathroom, so I'm trying to like get whatever I can.
Oh.
Thank you.
So if the, like you see, the sun in this case is clear over here to the left, or yeah, over here to the left, okay? So when she holds that moon up over here, okay, the lit part, just like you saw me a minute ago, the lit part, you don't see any of it, and that's a new moon. Okay, and notice that here in a minute you're going to see her go, it's going to go counterclockwise. So the next position is over here. That's what we're seeing tonight. Okay, and the next position is here. Yeah. So a few things about this is it's called, well, I think it works well. If whatever is over here on the right, it will continue to the left, whether that's darkness or lightness. In this case, we have lightness that's continuing to the left. Okay? And since it's getting brighter and brighter, we call that process waxing. See the waxing crescent? Okay, so there's first quarter. By the way, from here to here, it took about 7 days. There are four main phases. New moon, first quarter is the main phase. Let's go 7 more days. Full moon is another.
Thing's gonna be.
Full. I kicked the ball.
What does that say, waxing what?
Waxing gibbous. Yep. So between first quarter and full moon, it's about 7 days. And then, okay, the moon continues to orbit the Earth. And so between full moon and third quarter, it's about 7 days. So now go ahead and kind of go from, did I say left to right? Okay, go from right to left again. And so actually here, after full moon, see what's happening is the right is overtaking the left. What's happening, the dark is overtaking the light. And that's kind of how I remember it. So when the dark is overtaking the light and it's actually past full and it's on its way to kind of getting smaller and smaller, we call that process waning. And that's why you see the word waning up here, a waning gibbous. Okay? So quarter moons, by the way, are always at right angles. Okay, so The moon was here, we call that new moon. The first quarter is at a right angle, okay? The full moon, straight line with the sun. The last quarter, again, a right angle. So just to finish it up then, we have on its way to new moon, we have another waning, but it's a crescent. Okay, I can't, those blue words I think will be fine. All right. Can you use notes on your test? You can use a note card on your test. Yeah. So
Like
however
one
much.
note card?
One note card.
Okay.
One big
You
note
give
card.
us the what?
I'll give you like a review sheet. Yeah, kind of give you hints what topics will be on the test. And I'll throw a review session. And you're welcome to come to that and get points, get extra credit points for coming to a review session that I talk about the test ahead of time.
When is our test, do you know?
I do, and I can tell you after I have an idea when it is, because I'm keeping. I have 3 sections I'm kind of keeping together. So,
Do we only see one side of it?
we do only see one
Is it
side.
always the same side?
Mm-hmm. It is. And I have a
So
slide
it
coming
does
up.
not itself rotate?
Actually, the reason we only see one side is because it does rotate.
Oh.
Yeah. Hang on, hold that thought, okay? So I'm going to come back to that because I love that, and that's important to know. So you kind of see what's going on here from the new moon, right? Okay. Here are some words to go along with words that you saw on the previous slide. And I said there's 4 main phases: the new, the first quarter, the full, the last quarter, and the new again. That's 4, yeah. But between, we have something called a crescent and a gibbous. So if it's a sliver, we use the word crescent with slivers, okay? If it's bigger than a quarter, we use the word gibbous with bigger than a quarter, okay? And I already kind of mentioned this before, if it's getting bigger, we use the word waxing. If it's getting smaller, we use the word waning. So you mentioned note cards that you can take your test with you. I would put these on the test, you know. Or else you already know them. Okay, so past full then, on its way back to new, we have a waning process. Past full, on its way to being between the earth and the sun, new, it's getting smaller. So we call it waning. First we have a waning gibbous, last quarter, waning crescent, the thumbnail.
It seems complicated, but it's really not.
Right.
We're just trying to figure out the way it's this.
Yeah. Everybody thinks things differently, so.
Yeah. There's just a lot of movement going on.
There is a lot of movement. Totally. Okay, so notice that what your author's done is use a little bit of scale here. This is the moon, sorry, that's the earth, and that little drawn to scale is the moon. I think drawn to scale. So the gray is showing you the moon's orbit, okay, around the earth. And it's kind of like I mentioned before, that the orbit is lopsided. Sometimes the moon is closer to the earth than others. And that's all that is. And I actually have the words associated with the close time is over here on the left. It's called perigee. Just like perihelion is close, perigee is when the moon is closest to the earth, like perihelion, closest to the sun. And apogee is like aphelion. So here you go. Have you ever heard of supermoons? Okay. Yeah, they can look really big. And supermoons happen when the moon is full and the moon is close to the earth. So super moons, perigee, full moon. That's all you gotta say. So full plus it being its closest place it can be to the Earth makes it a super moon. And we have one more super moon. There's been 4 super moons this year recently, coming up in September.
They're really cool.
Yes, they are. They are pretty. Okay? All right. Okay, on to this. Do we always see the same side? And seeing the same side, if something is in sync, okay, to me, it's kind of going side by side, in sync. The synchronous rotation, the sync I'm going to talk about is the fact that the one of the moon's side is basically synced into the Earth. So we always see that side. It's called synchronous rotation. And I think she does a pretty good job, and I'm going to kind of mimic what she does. So what she's doing up there, I'm going to do. I'm going to have to switch it up a little bit, because I'm going to be the moon. Okay, and we're going to, yes. Ta-da. And we're going to switch that from the sun to the Earth. Okay, that's the Earth, and I'm the moon. Okay, and so of course I orbit the Earth. So here we go, just like she's doing. So let's go ahead and make the sun over there. Okay, the sun's over there. So what phase are we in? What phase am I in?
New.
Not new. Full. Full. Very good. Yes, you got it. Okay. So now watch what I do. It's kind of like what she does. Okay. I am going to go 1 week, about 7 days. Okay. But watch me I'm going to kind of do this. Okay. About 1 week later. Okay. What phase am I in now? Last quarter. Yeah, I'm in last quarter. Okay? I'm in last quarter because basically the sun is shining on one of my hemispheres, and this part back here, the Earth can't see, so it sees a half circle. Now, watch carefully, okay, because I'm going to go 1 more week. Okay, I'm just gently turning. I'm totally just gently turning. Okay, so what phase am I in? If that's new, very good. And then I'm going to go about 1 week later. What phase am I in? First quarter, yeah. Okay. Now, if you were to track my movement, what I did was one single little rotation on my axis. But the one single rotation took the same amount of time as my orbit. I spun on my axis the same amount of time I did one orbit. That's the same. And in doing so, the same side is always facing the Earth. Here, put it another way. Okay, so I'm not going to spin. Here we go. I'm not going to spin. Not going to spin. Not going to spin. Let's see how do I do that. Okay, if I'm not spinning, I'm always going to keep that face that way. So that's hard to do. Okay, this is not what the moon does. The moon spins. Okay, if the moon didn't spin, they would go like this. But the moon does spin once. It spins once on its axis, the same amount of time it takes to orbit the Earth. I don't know if you're convinced, but that's it. It's called synchronous rotation.
And this hints with the Earth.
Well, I guess one way, I probably misspoke, a better way to say it is it syncs with itself. Its rotation is in sync with its orbit. Yeah, I don't think you're convinced. Now, I brought something, I brought in a photograph that was taken a long time ago by the Galileo mission. I'm like, but it just caught my attention. Because I'm going to show you side by side the side of the moon we always see, we call the near side, and the side of the moon we don't see, we call the far side. Okay. So side by side, if I were to ask you, how many people think this one over here on the left is what you see when you look up at the nighttime sky at the moon? Me too. Kind of those dark regions, those are called mare. Okay, and then you kind of see some highlands. They're cool. They're the lighter regions. What's wrong with that one over there on the right? It's all cratered. It's got, yeah, it's dark spots. Okay, so that's not by accident either. This exposed hiney, okay, it's taken a beating. It's kind of the way I think of it. Okay, so this is, that over there is the side that you don't see. It's the far side. I have to think. So the last topic is our eclipses. And we have a pair of eclipses coming up. I'm so excited. Let's see. I meant to look, but you guys know that what I've done, one of the things I've done differently is to, over here on the right, there's a Google Calendar, and it has the lab dates on it. Oh, that was so clever. Oh, you're fine. Okay. So much for clever. All right. Let's see how this is loading. Not bad. Okay.
Do you post our grades online as well as hand them back to us?
Yeah.
Okay.
A lot of times I don't update the grade book until like test time. But that's on my list of things to do better with, so we'll see. Okay, so over here, we can see when the eclipses are, because I put them on the calendar. See, isn't that just adorable? I know. Oh, and see down here, there's a picture that I showed you. Let's see. Anyway, so here you can go to September, October. So they're in October. See this 4 a.m.? Total lunar eclipse on the 8th. Okay. And what you're going to see here is basically lunar eclipses can only happen when, we're going to turn that back into the sun again. I'm going to be the Earth and my fist is going to be the moon again. Okay. Basically at full moon, if it's lined up just right, okay, the Earth blocks out the sun from that wannabe full moon. Okay. So we can get a total eclipse of the moon. Now this one, I'm going to give you details later, but I really think you and a friend can actually catch this on your own. It can be something you can do by yourself. Lunar eclipse, and I'll try to give you some details. We got time. But it's awesome, okay? The solar eclipse, I'm not going to make for on your own credit. You're going to have to, I'll get out the telescopes, but I'm not comfortable with turning you loose on a solar eclipse. The solar eclipse is going to happen about 2:30 our time. It's on a Thursday. Okay, the solar eclipse, then this is the Earth, okay, sun. The solar eclipse basically happens when the moon gets in the way of the solar disk. Okay, so this is the moon, and it basically gets in between the sun and the Earth. Okay, solar eclipse. And I'll give you details about that. I will get out the telescopes, but I don't know what time it'll be. It'll be on the hill, blah, blah, blah. We have class that night. What do you think we should celebrate? Okay, so more details coming. But you have to come and partake. Okay. So eclipses, some slides to I kind of gave you the nuts and bolts of eclipses just now, but there's just a little more to say. Okay, so we have an eclipse of the moon, called a lunar eclipse. And then we have an eclipse of the sun called a solar eclipse. So an eclipse of the moon looks like this. So you kind of see the configuration. It will only happen, and there's definitely some test questions I can pull with regard to eclipses, and I think you have a homework question. It can only happen when the moon is in its full phase. Okay? Solar eclipse can only happen when the moon is in the way in its new phase. Okay, solar eclipse can only happen when the moon is in its new phase. Okay.
So a total solar eclipse is going to be happening in?
It's a partial
It's a
solar
partial,
eclipse.
okay.
About almost 2 weeks after our lunar eclipse, we have a solar eclipse. And I'll kind of tell you the difference between, for the sun, a difference between a partial solar eclipse and a total solar eclipse. That's coming up. Okay. So the Earth and the Moon both cast shadows from the sun. Sometimes those shadows are just into outer space. Okay, if you ever made like little shadow people, okay, you are basically blocking some of that light and casting it onto the wall. Okay. So when at certain configurations, when the moon passes into the Earth's shadow, you see how I did that? When the moon passes into the Earth's shadow, okay, you can get a lunar eclipse, or when the Earth passes into the moon's shadow. Okay, that's one way to look at it. The moon's blocking out the sun. Okay, the Earth's passing into the moon's shadow. We can get a solar eclipse. So there's the two kind of shadows that can be cast. Okay. Now you see, especially kind of the shadow cast by the Earth. The shadow cast by the Earth. It's kind of a common thing. You see the umbral part of the Earth's shadow. That's the dark part. And then you see the umbral part, penumbral, excuse me. Penumbral is this light shadow, and the umbral is the dark shadow. Okay, dark shadow, light shadow. All right. So let's pick on the lunar eclipses first. So there are kind of little flavors of lunar eclipses. There was a lunar eclipse, it would have been a couple years ago, like in December, like the first week in December, and I talked my husband into going out to the observatory to watch this eclipse of the moon because it was a total lunar eclipse. Okay, if you've ever heard of the blood red moon, okay, they call it totality. When how do I say this? This is the moon over here because we have a lunar eclipse. Totality is when the moon is entirely in the Earth's darkest part of a shadow, the umbral part of the Earth's shadow. That's a total eclipse. We call that totality. Oh. My battery's dying? Okay, talk fast. Okay, a penumbral eclipse is, first off, so that's total eclipse. A partial eclipse is, can you see this up here? Where you kind of have this, the moon is going into the penumbral part, which is okay, and a bite is taken out in the dark part of the Earth shadow. That's a partial. And then do not even bother to get up for a penumbral lunar eclipse, because you can just barely tell it's even going through anything. Okay? Just don't do it. Okay, eclipses of the sun. They can only happen when the moon is in its new phase. Okay, so here you see the moon in its new phase, and you can see over here the shadows that are cast by the moon. You see that kind of cone, sort of like a triangular. That's the umbral part of the moon shadow. And then kind of the lighter cone around it, that's that penumbral part of the moon shadow. So in October, we're not going to have a total solar eclipse. A total solar eclipse is basically the disk of the sun is entirely blocked out by the disk of the moon. Oh, really?
7%
What's that?
7% went fast.
Was it 7%?
Yeah, that's what it said.
Okay. We got it, because we only have a few more slides, right? Okay. So I need to finish telling you about solar eclipses. Let's see how long this takes to come up. So you have the total solar eclipse, which we don't. And then we are going to have a partial solar eclipse. And I bet you guys can partial solar eclipse. So a partial solar eclipse basically is, I like to think of it as the disk of the sun and the disk of the moon, okay? Basically, you can see a bite taken out. You can see a bite taken out of the sun's disk. And that's what's gonna happen in October. But the problem with that is safety, because with a total solar eclipse, you get the entire disk of the sun covered up, okay, the total solar eclipse. With this partial solar eclipse, you're gonna have all sorts of energy coming from that sun that could fry your eyes just like that, okay? So actually, there's a good chance, and I think this is right, could be said, you won't even know that this is happening. Okay, the sun will still be so bright. This you would know. This you would not, okay? So we'll get out the sun scopes and see what we can see, okay? The sun scopes basically are the telescopes you saw. There's a couple different types, but I get that big telescope out and I put like a mylar sort of welder's glass thing over the front of it. We also have another sun scope. Didn't I tell you because mine got stolen? We'll see if we have that one set up and running yet. Let's see. The other one is an annular solar eclipse. An annular solar eclipse looks like this. Okay, disk of the sun. This is the moon's disk. The moon basically is kind of close to the earth, so that you end up with it's not quite big enough. The disk of the moon is not quite big enough. So have you ever heard like a ring eclipse? At totality, you're just going to kind of see a ring of the sun. Okay. The last slide, did you guys find Waldo then? When I say find Waldo, find a missing word. Are we okay with that slide?
The moon's orbit is 0.5 to the ecliptic plane.
Okay, that word is inclined. So let me just explain. I'm not going to bother bringing up the slides again. Let me explain that last slide, okay? Are we okay with solar eclipses? Okay. So here's the deal, and my husband and I have talked about this. So why don't we, every full moon, have an eclipse because the moon's going to pass through the Earth's shadow? And why every new moon don't we have an eclipse of the sun because the sun's going to block out, excuse me, new moon because the moon's going to block out the disk of the sun? And the answer to that is this, just like you see on that, the incline. Basically, as the moon orbits the Earth, okay, that orbit doesn't lie in the plane of the ecliptic. It's tilted out about 5 degrees, and that's kind of what you're seeing on that slide. Okay, so only if it's just right, when they talk about nodes and all that. But if its plane did lie, if the path that the moon takes around the Earth did lie in the plane of the ecliptic, we would have a lot more eclipses. Okay? Okay. Well, I got right about 8:20, so.
Does total eclipse happen like once every 7 years or something like that, the solar eclipse?
There's like some rules for them, and you have to be at certain locations. So, but no, I think they happen more than 7 years. I think 7 might be like the number of eclipses, eclipses of the sun and the moon you generally have in a year. A lot of times you have to travel to the middle of nowhere to observe the eclipse.
Because I remember when I was in elementary school, and they brought us outside, and I was like, you have to, the teachers kept saying, you have to have sunglasses, or you can't go outside, because it can dry your eyes or something. And I got in trouble because I took my glasses off. They're like, this is only gonna happen once every 7 years. And I'm like, then I'll see it again in 7 years. Because they made me go inside.
We made those little boxes when I was little.
You made
With
those
a little
boxes
pinhole.
with a pinhole, and it projected, or it came through and it showed you that eclipse was happening? Yeah.
It's supposed to be safe.
I'll have to look into those again. And kind of like that, during an eclipse, you can see kind of the shadow that's being cast on like trees. I don't know, I mean, leaves.
Would you mind telling me what that last blank was?
That last blank, incline. Incline. Does that make sense? Any other questions?
Just
Okay, well, enjoy those clear skies. Is it clear out there?
Peter probably
You see it?
You can see a better stand back here than up close. Hold the blinds up a little bit more.
We're looking at it.
Yeah.
Now can you see it? So drive carefully, everyone.
Here. Come towards the
Okay, let me know if you have any questions. So chapter 2 is due next week. Awesome. Yes.
In our test, did you?
Oh, yeah. I can, if you have a minute.
I do.
And I will try to email everybody.
I'm
this
not
too.
going anywhere but Sonic.
Oh, good choice.
That sounds yummy.
That does sound good, I always forget about that.
Well, it's gonna be my new Thursday night thing. I'm here all day. Well, you have a longer day than I do, but I'm pretty much here all day.
We're looking to see when the test is.
At least they have good food here at North Point. I don't know.
I don't know what they're doing. You're not gonna get very far, are you?
I forgot that I dropped them on the chair.
Disturbing everybody.
Right? The phone kept buzzing. I should have never texted her to ask her about that.
At least you didn't break the world.